All right, did you get a chance to read that first story about countertops? Let's look at it again. The marginal cost in dollars per square foot of installing X square feet of kitchen countertop is given by C prime of X equaling X to the 3/4 power. Okay, so I wrote down the function, the derivative function actually. I wrote down what it represented. It represented the marginal cost. I wrote down what X represented. It represents the number of square feet of counter space, countertop. And now they have two parts. So part one is asking us to find the cost of installing 40 square feet of countertop. Okay, got it. So 40 square feet of countertop. Well, they want the cost, don't they? They didn't say the marginal cost. And by the way, do you remember what it means when you hear the word marginal? Yeah, it means they're finding that rate of change, in this case per square foot. But that's not what we're looking for. We're looking for the actual cost. So how am I going to find the actual cost? Good. I'm going to have to take the antiderivative. Excellent. So for part A, to find the actual cost, we're going to have to take the antiderivative of x to the 3/4 power dx. Now, here's the deal. They want the cost for installing 40 square feet of counter space. So, what do you think, or how do you think we're going to evaluate it if we want 40 square feet? Yeah, you're saying plug in 40. I totally get it. Now, since we are working with definite integrals, we can approach it a little bit differently than we did in a previous lecture. In this particular lecture, we're actually finding the cost from 0 to 40 square feet of countertop. So on the integral sign, I'm going to put 0 at that bottom, 40 at the top, and now I can evaluate it a little bit more directly, shall I say. Cool? All right, so take the antiderivative. What are you going to do? Yeah, 1 over the 3/4 plus 1, x to the 3/4 plus 1, and then you're going to evaluate it from 0 to 40. So 3/4 plus 1, yep, 1 over 7/4 times x to the 7/4. Still evaluating from 0 to 40. And that's right. The cost function becomes 4/7 x to the 7/4 from 0 to 40. Do you agree? Excellent. Okay, time to evaluate it, which means we are going to plug in the 40. So 4/7 times 40 to the 7/4 power minus 4/7 times 0 to the 7/4 power. Cool? Okay, get those calculators out. I already got mine out. I already have my answer on this. What did you get? Okay, so I got the same. I got $363.55. And unless one of us finger punched incorrectly, we're agreeing. Good? Okay, now there was a part B. They want the cost of installing an extra 18 square feet of countertop after they already installed the first 40 square feet of countertop. So you're like, gee, I wish they'd get it straight. I know, but, they decided to do a bathroom. I don't know, whatever. So here's the deal. What do you think we're going to do to find the cost of the extra 18 square feet? I need cost, right? Okay, so to find the cost, you're going to take the antiderivative of that marginal function. And you're like, we did it already. You're right, we did, but bear with me a second. I need an extra 18 square feet, which means you're going to have a total of how many square feet? Good, 58. Now, here's why I'm rewriting this as an integral. I am purchasing, or they are purchasing, a total of 58 square feet. So I'm going to put the 58 at the top of the integral sign. My question to you is this. The number at the bottom of the integral sign, will that be 0? Yeah, it won't be very good because I'm looking for an extra 18, right? So that's going to start at 40 because we already got the cost at 40 square feet. We need the cost for the additional 18 square feet. Good? Does that make sense? Okay, so we already found the antiderivative, did we not? So let's see, the antiderivative, the cost turned out to be 4/7 x to the power of 7/4, and now I'm evaluating from 40 to 58. Cool? All right, so when we do our work, when we plug things in, we're going to do 4/7 times the 58 raised to the power of 7/4 minus 4/7 times 40 to the power of 7/4. All right, I know your calculators are out. Talk to me about the first one. What do we get? Okay, hopefully we're agreeing. I got $696.56. And I'm subtracting from it a number I already know, because didn't we already figure out 4/7 times 40 to the 7/4? Yeah, we got that over here. We got $363.55. And when we do that subtraction, the cost for the extra 18 square feet is, well, at least I got $333 and a penny. And unless I finger punched incorrectly, there's the cost of the 18 extra square feet. Cool? Making sense? Loving it. So we've worked on this type of problem before, like I said in a previous lecture. However, now that we have these definite integrals, it makes it a lot quicker. It makes it more direct in terms of what numbers I need to evaluate at without going, hey, disregard any fixed costs and all that other stuff. Cool? All right, be right back with another one. Let's look at the next story. A company estimates that the sales or its sales will grow continuously at a rate given by the function s prime of t equals 21 times e to the t. So it's a rate, which doesn't surprise us that they've given us a derivative. Agreed? Okay. S prime of t is the rate at which the sales are increasing, and that's in dollars per day, and t is the number of days. Now, two parts, so let's look at part A. Part A is asking us to find the accumulated sales for the first 3 days. So what are we going to have to find if we need the sales? Good, we need to find S of t, which means we need to find the antiderivative. Excellent. 21 e to the t dt. Now, what are you going to label on your integral if it's for the first 3 days? Good, it's going to go from 0 to 3. Excellent, good job. Okay, so I am going to take that 21 out, right? Because since it's a coefficient, I don't need it in there. So I'm actually trying to find the antiderivative of e to the t. So what's the antiderivative of e to the t? Good, e to the t. So we have 21, and e to the t is the antiderivative, which we're evaluating from 0 to 3. So here's the benefit of taking that 21 out. What we're actually going to be doing is 21, and in parentheses we're going to multiply by e to the power of 3 minus e to the power of 0. Cool? Good. Now, it's interesting because some people go, well, why is the 0 the bottom number? Well, you're minusing out day 0 is what you're doing. Because you start on day 1, 2, 3. So you're minusing out day 0, so to speak. So when you do this work here, you get your calculators. I already have my handy dandy cheat sheet because I did my calculations. So when you do this, our cost for the first, or our sales for the first 3 days I got $400 and I think I wrote 80 cents. That's not good if I can't read my own writing, is it? Anyway, hopefully we agree, and if we don't, just know that I could read my own writing. Cool? All right. Now, there's a part B, and part B wants to know the accumulated sales from the second day through the fifth day. So, part B, how do you think we're going to handle part B? Yeah, we need the sales, right? Which means I need the antiderivative of 21 e to the power of t dt. Now, here's the question. If I need the sales from second day through the fifth day, the question is, how are you going to label your integral? So what numbers will you evaluate it at? Good. You know the top number is 5. Now, some of you are saying the bottom number should be a 2 because you're starting at day 2. I get why you say that, but bear with me. I'm going to tell you we're going to start at day 1. So hold that thought one quick second. We already took the antiderivative of 21e to the t. So we know we have 21. And in parentheses, where our antiderivative was e to the t, which we're evaluating day 1 to day 5. Now, here's the reason you actually have the bottom number as day 1, because you're subtracting out. When you do this evaluation, you will be subtracting out e to the first, which is day 1. When I take day 1 away, it will leave me with days 2, 3, 4, and 5. Understand what I'm saying? That's why you start at day 1 on the evaluation, because it'll wipe out day 1. You're subtracting out day 1. If you put this 1 as a 2, that means you're actually subtracting out day 2. I don't want that. I need day 2 in here. Make sense? Okay. So the sales for days 2 through 5, I know, get your calculators out. I already did my computation. Hopefully we agree on the sales. I got $3,095.68. Did you get the same? Awesome. So far so good? Cool. Got another one for you. Ready for the next story? Let's read it again. Assume the annual rate of change in the national debt of some country, and it's in billions of dollars per year, can be modeled by this particular function. No surprise, the function is a derivative function, right? D prime of t. And equals 840.97 plus 827.88t minus 192.54t squared plus 16t cubed. Lovely little function. And they tell us t is the years since 1995. Good. They're asking us by how much did the debt increase between 1996 and 2003. So they're looking for how much the debt increased, right? Are they looking for a rate of change, or are they looking for how much it increased? They're looking for how much it increased. So what are we going to have to do? Yeah, we're going to have to find the antiderivative of that lovely function. So hopefully you have that function written down already. And so I'm taking the integral of, as I mentioned, 840.97 plus 827.88t minus 192.54t squared plus 16t cubed, all in parentheses, dt at the end. Now, the question is, what's going to go on your integral? If they want the debt between 1996 and 2003, what are you going to put? Yeah, 1996 was year 1, correct? And 2003 is year 8. Good? All right. So now we have to take the antiderivative of this lovely thing. And gratefully, there's a bunch of minus signs and addition signs between them, which means we can look at them separately. So I am going to use my handy dandy cheat sheet. Actually, I don't need it quite yet, but I am going to need it in a moment. So when we take the antiderivative, that will be 840.97t plus 827.88 divided by 2 times t squared. Because remember, the antiderivative of t is 1/2 t squared, right? That's why the 827.88 is over 2 minus 192.54 over 3 t cubed, right? Because the antiderivative of t squared is 1/3, right? Okay, and then plus 16 over 4 t to the power of 4. And we're evaluating from 1 to 8. Good? Y'all with me? All right, so we can do some simplifying just to make sure we're on the same page. So we have 840.97t plus 413.94 t squared minus 64.18 t to the third plus 4t to the power of 4, evaluated from 1 to 8. Okay, so I suggest you pause the video at this point, plug in the 8, see what you get, plug in the 1, see what you get, and hopefully we'll get the same numbers. So tune me back in when you got those. Okay, got them? Here we go. Here's what I got. For t equaled 8, when I plugged 8 into this 4th degree polynomial, I ended up with, I need my cheat sheet, $10,856.97. And when I plugged in for 1 for the t, I ended up with $1,194.73. And I have to subtract them, don't I? Okay. And we have $9,662.24. Do you agree? Good. But mind you, this isn't $9,000. Why? Because these are in billions of dollars. So we have the word, they do a shortcut and they put the word billion at the end as opposed to putting the zeros and all the commas. Cool? Okay. The only reason we would get this wrong is we finger punched incorrectly, but I'm assuming we both got it right. Stay tuned. One more. Ready for the next one? A company is producing a new product. Due to the nature of the product, the time required to produce each unit decreases as workers become more familiar with the production procedure. It is determined that the function for the learning process is given by 3 plus 0.4 times 1 over x. Now they tell us the t prime of x is the learning process time. Well, that's actually the change of the learning process. They didn't use the word change, but they mean change, trust me. And x is the unit number. They would like us to find the total time required for the new worker to produce units 1 through 10 and then 20 through 30. Well, I can't do 1 through 10 or 20 to 30 until I get my antiderivative, right? Because I need the total time. All right, so here we go, the total time. We need to take the antiderivative of 3 plus 0.4 times 1 over x dx. Now, the first question was units 1 through 10. So great, 1 through 10. That's what I'm going to do. Now, I'm going to work this problem out by literally splitting these two apart. There's a reason for it, and I'll show you what that is in a second. So I have the integral from 1 to 10 of 3 dx plus the integral from 1 to 10 of 0.4 times 1 over x dx. Now on the second one, can't I take the 0.04 out? And that's exactly what I'm going to do, is I'm going to take that coefficient out to make life a little bit simpler for us and more obvious, shall I say. All right? Okay. So on the first integral, we would just get 3x, correct? And we're evaluating it from 1 to 10. On the next one, we're going to get 0.4. What's the antiderivative of 1 over x? Yeah, that's the natural log of x, isn't it? And this is supposed to be in absolute values, that x. Agreed? And I'm evaluating this from 1 to 10. Cool? Okay. Now, here's the deal. Since we're evaluating both of them from 1 to 10, I'm just going to kind of put it back together and say in parentheses 3x plus 0.4 times the natural log of x evaluated from 1 to 10. Notice I didn't put the absolute values around the x because the numbers I'm plugging in are positive, so it's not really going to make that much of a difference if I keep the absolute values, will it? Good. Just checking. Okay, so plug in the 10. We end up with 30 plus 0.4 times the natural log of 10 minus, plugging in the 1 will give you 3 plus 0.4 times the natural log of 1. Okay, I know you got your calculators out. I know you're doing your handy dandy finger punching, calculator punching, and you get yours, I'll get mine. We're going to round to 2 decimal places. What did you get? Good. Sounds like we got the same thing. 27.92 hours. That's the total time it takes them to produce units 1 through 10. And now, yeah, like part B, shall I say, they want units 20 through 30. So the total time is now going to be the integral from 20 to 30. Nothing else is going to change, is it? We already took the antiderivative. We're not changing our derivative function. We already took the antiderivative of it. So in actuality, we are working with 3x plus 0.4 times the natural log of x, and now we're evaluating from 20 to 30. Agreed? Yeah. Once you find the antiderivative, they can ask you a whole bunch of different possibilities, and gratefully the only work is plugging in the numbers, the new numbers. All right. Assuming we do this correctly. So plugging in the 30, we're going to have 90 plus 0.4 times the natural log of 30 minus, plugging in the 20, 60 plus 0.4 times the natural log of 20. And when you do your calculator punching, again, round to 2 decimal places, what did you get? Yeah, I got the same thing, 30.16 hours. That's our total time. Cool? Okay, loving it. No surprise, got another one. Okay, did you read the next one? Let's look at it again. Look at it again. Suppose that in a memory experiment, the rate of memorizing is given by this derivative. No surprise, negative 0.009 t squared plus 0.6 t. Where that m prime of t is the memory rate, it's in words per minute, and t is in time, which is also in minutes, which is a good thing. Their question is, how many words are memorized in the first 10 minutes? Well, got an idea of what you're supposed to do? Yeah, here we go again. We are dealing with taking the antiderivative from 0 to 10, because it's in the first 10 minutes, so I have to subtract 0 minutes, right, of negative 0.009t squared plus 0.6t dt. Okay, so here's the deal. I am going to assume that you are very good, I needed my cheat sheet, that you are very good at taking the antiderivative at this point. So I'm going to write down what I got for the antiderivative, and hopefully the two of us agree. I got negative 0.003 t cubed plus 0.3 t squared, and I'm evaluating from 0 to 10. Hopefully you got the same thing. Cool? All right. So I'm plugging in the 10. I'm plugging in the 0. When I plug in the 10, I get negative 3 plus 30. When I plug in the 0, I get 0 plus 0. So in this particular case, I get 27 words. That in the first 10 minutes, 27 words are memorized. Good? Okay. Now, I have two more problems for us. In these next two problems, we're going to be talking about velocity, acceleration, the position of that vehicle at whatever time. So get those thinking caps on. Get a new piece of paper so you can take some notes as we work, and I'll be right back.